So we're gonna look at pretty much the whole course is focused around functions. What are functions? Okay, and we're gonna make a distinction between something that's a relation and then a function is a subset of a relation. Okay, so a relation is just a relationship between an x, y, and variable. Okay, and then a function is a specific subset of what a relation is. Okay, so a relation is a set of ordered pairs, x, y. So again, just a relationship between two variables. Okay, an example would be just 4 points on a grid, right? So you've got 2, 3, 4, 5, 6, 7, 8, 9. Those are just 4 points that would appear on a XY Cartesian grid, coordinates, okay? So a function, however, is a specific subset of a relation, okay? Such that the word definition is a little bit more complicated than the actual applicability, like the homework kind of questions that I'll give you today, and like kind of looking at a graph. But it's for every x value, there's one unique y value. Okay, that basically means like if you have one value of x, it has one unique y value associated with it. It doesn't have like your coordinate points on the grid don't have like 1, 6 and 1, -2 for one value of x. Does everybody see what I'm saying? We'll go through there's examples through the lesson, but okay. Every x has one unique y. That's the definition of a function, okay? And so you can see an example there. You don't have any repeated x values. That's kind of your first clue sometimes, is when you're checking whether or not you have a function versus a relation. Look for any repeated x values. Okay? So that example that's right below what the definition of a function is. It doesn't have any repeated x values, and so you know you're good. They're always relations, but then you're trying to further classify them as to whether or not they're functions. Okay, and that's your definition of a function. Okay, so to determine if the graph of a relation is a function, we use what's called the vertical line test. So the vertical line test actually just contextualizes in a very nice way that very wordy definition that we've had, or that we've just used. Okay. Okay, so determine, that's the vertical line test, okay? So that means the range of a relation is the set of, do we know what the range is? We have domain and range. Those are your two words. Do we know what range is in relation to a graph? Gabe?
Y value?
The y values, okay? So it's the y values. Do we know what we call the y values on a, do we know what we call the y values? There's two words. There's dependent and independent. Do you know what the y values are? Ricky? They're the dependent ones, right? So the independent variable we always put along the x-axis, and the dependent variable, the one that depends on the independent one, goes on the y, right? So the dependent variable are the y values. Okay? So determine if each relation is a function. Okay? So example A, we have those 4 points there, -2, 8, -1, 2, 3, 4, and 5, 6. Is that a function? Let's revisit your definition. For every single x that you see, I have one unique y. Does that example A satisfy that definition? Yes, it does. Okay, I can see every x I have. The other clue, again, as I alluded to, I don't see any repeated x values. Okay, so that's a clue that it could be a function. Okay, if you don't have any repeated x values, there's no way for there to be different y's associated with one x value, right? So this one's a function. Every x has one. Now, obviously with two examples, we're going to contrast that now. So what do you think in part B is true about those points? Function or not a function? Relation or function? Okay, they're always relations, right? Part A was relation as well. It was just a specific relation as a function, okay? They're always relations, okay? Anytime you start putting some points on a grid, it's a relation. We're just trying to further classify it as to whether or not it's a function, okay? And so I see here, for the value of 1, I have two different y values. Ever see that? Also for 2. And it just has to happen once. Doesn't matter if it happens like if I have multiple x values with multiple y values. If it happens once, it's a relation. Okay? So because I have these two 1s and the two 2s for x values and different y values associated with it, that's a relation. Okay? So it's not, in contrast, not a function. So if you needed further explanation, we could say, you can write this or not for yourself. There are multiple y values at x equals 1 and x equals 2. Everyone feeling pretty good so far? Okay, nothing crazy, not too crazy. Okay, you don't need any grade 10 stuff for this. Okay. Okay, the only thing you might require from grade 10 is the recognition of what an equation of a line looks like. It was y equals mx plus b. Or what the equation of a quadratic might look like. It's got an x squared in it, right? That's all you would need, okay? So A and B look at the word definition of a function specifically, and C, D, E, F, G, and H are now we're going to use that vertical line test just to test whether or not it's a function versus a relation. So, for instance, let me use the blue. So the vertical line test is exactly as it sounds. Okay, you draw a vertical line on your graph, on your relation, and you test whether or not 2 points touch that vertical line. If 2 points touch that vertical line, it means that at that particular value, in this particular instance, it's x equals -2. At x equals -2, I have two different y values. Everybody see that? So that's not a function. We've broken the rule. We don't have this unique, like for every x on this relation, we don't have a unique y. Okay, this one has 2. And again, it just has to happen once for it to not be a function. Okay, so at x equals -2, we have two different y values. That's not a function. Okay. Does anybody know? I was going to ask, do you know what that graph is? But it's a circle. Do you know what the equation for that is? Owen?
X squared plus y squared equals r squared.
Yes. Okay. So x squared plus y squared is equal to r squared. Okay, that'd be the equation of a circle. We're going to use that in a bit. I just want to make sure everyone's got that. Is a circle a function? No. Why not? It has lots of different, like multiple points where there are two y values for one given x. Lots of them. Infinite, in fact, if you're thinking from a rational perspective, right? So if I draw a vertical line on here anywhere, doesn't matter where I draw the vertical line, there's going to be 2 points where that vertical line touches the graph, right? So again, a circle is not a function. However, it is a relation, okay? So it's not a function. Okay, what about this? We're not going to get into what that equation is, but is it a function? Yes, because it doesn't matter where I draw a vertical line on here. Anywhere along this graph, it only touches once. Okay, so this is a function. And we'll say it passes vertical line test. Sorry, we're getting a little closer. Okay, F. Function or not a function? Not a function, fails the vertical line test. Just for everyone's benefit, does anybody happen to know what the equation of that graph is? The pre-IVs did it, which is why I know you guys know it.
Yeah, I'm trying to figure it out.
It's actually, what's it look like? Gabe?
I don't know exactly what it would be like, but I know it's like it's a parabola. It's just way like turned all the way.
Yeah, it's on its side, right? So a parabola, do you know the equation yet?
It's just x equals y squared.
X equals y squared. We'll explore that equation later as to where it came from and how it produced the graph, maybe in next week sometime, okay? But for now, you can use that little piece of information as like, that's an example of a relation that is not a function, x equals y squared, because it fails the vertical line test. Okay? G, why don't we do H and then we'll come back to G, because G is like, I'm sure some of you are stressed looking at G, so we'll come back to that in a second. This graph here, function or not a function? Sorry. It is a function. The other one, H. H is a function. And it is a function because it passes the vertical line test. You're going to all see this next week as well. Do we know what the equation of this is? Just out of curiosity. It's the graph of y equals the absolute value of x. Okay. That would be an example of a function. Okay, and again, we'll see that next week, how to produce the graphs, all that stuff. Okay. Let's go back to G. G is what we call a map. Okay, and it's mapping points. So this is just a fancy way of like condensing a big long list of coordinate points. Okay, so they have the possibilities for x and what they map to in the y, right? So for instance, 2 of the points here would be -1, and you just follow the arrows. So you'd have -1 and 3 would be a point, -1 and 4. Everybody see what we're saying? So you just follow, like, you start here at -1 and you follow the 2 arrows. Now, I'm not going to do all the coordinate points because I don't think that's a great use of time, especially when we should be able to come to a conclusion right now. Is that a function or not? It's not a function, and we know that to be the case because right away at -1 I have 2 y values. Right? And you can kind of tell with these questions, the maps are nice because if you see 2 arrows leaving one particular value of x, not a function. Okay? Does anybody have any questions with that so far? They're okay? Okay. So when we come down here, this is going to formulate some work we do next week, being able to like produce graphs from an equation. That's going to be big. But just to reiterate some other terminology. Okay, so we're going to determine if this equation d equals 1/2 t squared is a function. Okay, where d is the distance in meters and t is the time in seconds. Okay, so we're going to recall this dependent and independent variable. So dependent variable in this particular question is what? D, which is the distance, right? So the distance in which somebody travels depends on how long you're traveling for. Everyone agree? So most of the time, if time is involved, time is the independent variable. Why might that be? Can you alter time in any way? No. So it's independent of everything else. So if your question involves time, time is going to be the independent variable, and other things are going to depend on that time, right? Because you can't just stop and start time as you please. It's just going to keep going. Okay. So in this particular instance, distance is going to be the dependent variable. Okay. That's the y-axis. And the independent variable is going to be time. Okay, the x-axis. So, let me ask you a question. Technically, this is a graph that we've seen before. Does it make sense for me to substitute time values in the negatives? No, so I'm not going to do that. Okay. Can't go back in time yet. So I'm not going to substitute time values in the negatives. Okay. So those are our time values. And then our equation, which you would have seen at the top, d is equal to 1/2 t squared. What am I doing? How do I find the distance, Bryce?
You put the time value in your equation.
I just substitute the t value that I'm interested in. In this case, it's 0, 1, 2, 3, 4, all 5 of those entries. I'm interested in where this object is at time 0, time 1, times 2, time 3, times 4. Okay, if it's in seconds, it's in seconds. Okay, so I'm gonna physically, I'll do this once. Okay, so we can all see, and then you should be able to do the rest. Okay, I took the time value, whatever it was, I substituted it in for t, and then I get a distance, right? So 0 squared is 0 times 1/2. The distance in this question, or this at this time value, is 0 meters. You just do it again, right? Just replace that yellow piece, just changes, right? You're going to put in 0, 1, 2, 3, and 4. Okay, so 1/2, we'll do another one. 1/2 times 1 squared. 1 squared is 1 times 1/2 is going to be 1/2, or 0.5. I'm okay with the decimal for this, and we're going to plot the points. 2 squared is 4. Half of 4 is 2. 3 squared, half of 9, 4.5. 4 squared, cut in half. 4 squared, 16. Half of 16 is 8. Okay? Do we think this is a function before I put the graph on? I think so too. What's your clue? I'm never going to have a repeated y value here, am I? Not for any given x. I could plug in x's till 1,000,000. I'm going to get one unique y every time. No repeats. Everyone in agreement? So this is a function. And I can tell that from the table of values, okay, just by using our word definition. If I go over to the graph and I actually plot it, I'm going to have time on here and distance on the y, okay, and I'm just going to plot these points. 0, 0, 1, 0.5, 2, 2, 3 and 4.5, and 4 and 8, which I think is up top. Maybe I'm wrong. I think that's right though. So again, we're gonna ask you to come up with make a decision whether or not something's a relation versus a function in multiple instances, right? And being able to go back and forth is gonna help you. Okay, so being able to represent this with like a verbal definition as well as a graphical definition with the vertical line test and interchanging those is going to help you lock this concept in. Okay? Does anybody have any questions? We now maybe get to the part where you maybe have a little bit of grade 10, 9 knowledge that you're gonna have to pull on, maybe. Well, definitely. Okay? You can choose, like if I gave you this question in a test, you choose to graph it. Sometimes it might be a multiple choice question, right? Tell me if this is a function or a relation or neither or whatever, right? So if I looked at A, do we know what that graph is supposed to look like from the equation without putting any points in or plotting anything on the grid? Do we know what that is, Dylan?
There's a line.
It is a line. Okay, it's a line. Okay, y equals mx plus b. Is a line a function? Ooh, good answer. How many depends do you think there are?
Like straight. If it's straight, it's just vertical.
Well, by definition, a line is straight.
Then just the vertical one.
Ah, very good. So all lines are functions with the exception of one. And I will draw that on there. Okay? So this particular graph, if we need a refresher on how to graph a line, we're going to start at 3. Okay? It's our y-intercept, and we're going to have a slope of 2. So the graph's going to look like this. Okay? So obviously this is a function. Okay? I don't need to plot all the points. Well, that's not very close, is it? Okay? That's a function all day long. Now, Dylan,
Yeah.
what did you say? What's an example of a line that is not a function?
Vertical.
A vertical line.
Have you already signed in textbooks, Mr. Mark?
I did, yes. Yeah.
Yeah.
Okay. So a vertical line obviously fails the vertical line test because it has an infinite number of y values for one given x. So that's not a function. Okay. What's the equation there? Dylan, do you know that? Does everybody know that? What's the equation of the red line? Just in case I put it somewhere and ask you to identify without graphing whether or not it's a function. What's the equation of the red line? When someone asks you that, look at the graph and ask yourself what is true about every single point on that red line. We ponder on that for a second because that's important. This continually gets mixed up, and we already touched on it a little bit today in a different regard. What is true about every single coordinal point from now to infinity on that graph, Gabe? Do you know?
The X value.
What is the x value?
It would be.
Is it 0? Let's go out. Here's your x-axis, right, RJ? That's good. You're on the right track. Where is it? 1, 2, 3, 4, 5, 6, 7. Ricky?
Would it be like y equals x equals 1?
So this is why, yeah. So this is the confusing part, right? Is it y equals 7?
X equals 7.
Again, let's revisit so none of us make this error. What is true about every single point on that red line? This is important because we're going to use this in Unit 2 actually, so it's good that we're referencing this.
Same x value?
It's all the same x value. So what's the equation? X equals 7. Ask yourself what's true about it, and then write it down. Vertical lines are x equals. Horizontal lines are y equals. Because we may as well draw one. Let me pick a different color. What if I drew this? Can we see that green line or no? Not great. What's true about all points along that green line? Y equals -5. Sorry, not a great color. I won't pick that again. Okay? Now, in the interest of time, what's this graph? In B. RJ?
A parabola?
It's a parabola. Does it matter what the parabola looks like
Yes. Well,
as long as it's not on its side? But that's not a parabola anymore. That's different. That's why I referenced that equation. A parabola is a parabola. It opens up or down. Okay, it does not matter what it looks like. If it looks like this, or like this, or like this, or like this, is it a function?
yes.
Yes. Doesn't matter what it looks like. Quadratics are functions. Okay. So when if I ask you on a test, maybe it's a whole bunch of them, a whole bunch of equations. It's a multiple choice question, for instance. I'm just thinking off the top of my head. Line, quadratic, circle, absolute value. Identify which one's not the function. You see what I'm saying? It's a quick little check there, right? Reference which one is a function versus which one's not a function from just the equations. Okay, so you could sit here and plot these points the exact same way. Maybe I could do one. So if I substitute, like if I picked a -2, -1, 0, 1, 2. If I substitute 0 in, and we're gonna do this next week too, just as a recap, y is equal to 4. Okay, so you can do that with all the points, all 5 points there, all 5 x values. You can produce all 5 y values. You will always find with a quadratic there will be no repeats in the y values. And so by definition, this is a function. All right, one more. Hey? Uno mucho. Is this a function or not? We've discussed this already. It's a circle. Are circles functions? No. Right? Okay, what's the graph look like though? How big? Oh. Owen said earlier, x squared plus y squared is equal to r squared. What does r have to be in order to produce 9? In other words, what's r? 3. Okay, so it has to be. Okay, the radius is 3. So if I ask you to produce this graph, terrible. This thing's driving me nuts. It's in the way all the time. A radius of 3 looks like this. Watch how perfect this is. Boom. There's your graph. Okay, obviously not a function. If you need further proof, fails the vertical line test. Okay. Does anybody have any questions before we get going here? Okay.